You already know what the Stone Age is. Early humans, rocks, fire, clubs, the whole caveman starter pack. Primitive, right? The bottom rung of the civilization ladder. Except here's the thing. The Stone Age lasted 3.4 million years. By comparison, the entire history of modern civilization, every empire, every invention, every city ever built, fits into about 5,000 years. So maybe the Stone Age wasn't so primitive after all. Maybe it was actually one of the hardest checkboxes in nature to tick. Which brings me to the question that has genuinely kept certain paleontologists up at night. Dinosaurs ruled this planet for 160 million years. 160 million. And in that time, they evolved into thousands of species, survived multiple extinction events, and developed some genuinely complex behaviors. So, did any of them ever come close to their own Stone Age? The honest answer is, we don't know. And the reason we don't know is more interesting than a simple yes or no. Because when you actually dig into what dinosaurs' brains were doing, what some of them were capable of, and what their living descendants are doing right now, the picture you get is deeply weird and a little unsettling. So let's get into it. Before we talk about dinosaur intelligence, we need to establish something first. Not all dinosaurs were the same, not even close. You've probably heard that the Stegosaurus had a brain the size of a walnut, and that's roughly true, a 5-ton animal running on something you could lose in your couch cushions. The giant sauropods, the long necks, Brachiosaurus and its relatives, had brains comparable to a tennis ball, despite, in some cases, weighing close to 100 tons. To put that into perspective, our brains are about 8 to 10 times physically larger than a tennis ball. And we weigh, let's say, a lot less than 100 tons. So sauropods? Not the candidates we're looking for. But here's where it gets more interesting. Dinosaurs split into 3 major groups: sauropods, ornithischians, and theropods. The first 2 were generally not doing great in the neurology department. But theropods, the group that includes most of the carnivorous dinosaurs, and crucially, the ancestors of modern birds, that's a different story. Within theropods, brain-to-body ratio climbed, neuron counts increased, and the closer a theropod was to the bird lineage, the smarter it seemed to get. Which means that by the late Cretaceous, the final chapter of the dinosaur age, there were animals walking around that were genuinely, measurably, the smartest creatures on Earth. The question is, how smart is smart enough to use a rock on purpose? The T-Rex neuron controversy. Let's start with the celebrity, because a study published a few years ago made a claim so bold it got picked up by basically every science outlet on the internet. The T-Rex, according to this study, had approximately 3,289 million neurons. Yes, million. For comparison, a baboon, an animal that has been directly observed picking up and throwing rocks, using stones to crack open hard fruit, has fewer. Which led the researchers to suggest that the Tyrannosaurus rex had the raw cognitive firepower to potentially use tools, solve complex problems, and maybe even develop primitive cultures. A T-Rex, building a culture. Now, most paleontologists pushed back on this pretty hard, and they had a point. Neuron count alone doesn't make you Isaac Newton. Where those neurons are located, how they're connected, and what they're actually doing, all of that matters enormously. And in the T-Rex's case, the current leading theory is that most of that neural power wasn't going toward problem solving. It was going towards supercharging its senses, smell in particular. The T-Rex likely had an olfactory system so powerful it could track prey across vast distances, which is impressive, but it's not tool use. There's also the small matter of the arms. 2 fingers, short, comically short, honestly, and a head the size of a bathtub filled with teeth. Not exactly the anatomy of an animal that's about to start chipping flint. So no, T-Rex probably wasn't approaching its Stone Age. But it also wasn't the smartest theropod, not even close. The dromaeosaurs, the real contenders. The animals that actually warrant serious attention were smaller, faster, and feathered. The dromaeosaurs, the family that includes Velociraptor and its relatives, had encephalization quotients, that's brain-to-body ratio, as high as 5.8. For context, dogs sit around 1.2, cats around 1.0. An EQ of 5.8 puts these animals in genuinely impressive cognitive territory. And unlike the T-Rex, their anatomy was actually suited to manipulation. Longer arms, 3 well-developed digits, fingers, essentially. Grasping capability. These were animals that could physically interact with objects in their environment in ways that larger theropods simply couldn't. Now, do we have direct evidence that dromaeosaurs used tools? No. And we almost certainly never will, because the fossil record is brutal about this kind of thing. If less than 1 in a million bones get preserved, imagine how unlikely it is to fossilize evidence that an animal deliberately picked up a specific rock and used it for a specific purpose. It's essentially impossible. But the hardware was there, the brain, the hands, the behavioral complexity, everything except a paper trail. The troodontids, the closest thing we have. And then there's the group that makes even serious paleontologists pause. The troodontids. Small, bird-like theropods from the late Cretaceous with some of the highest brain-to-body ratios of any dinosaur, full stop. These weren't just smart for dinosaurs. These were genuinely, by any reasonable measure, intelligent animals. Their nests showed higher structural complexity than anything else we found from the Mesozoic, with evidence of deliberate manipulation of the environment to create specific designs. Their metabolic signatures were almost identical to modern birds, and their forelimbs were well developed, with hands capable of real dexterity. The paleontologist Dale Russell once ran a thought experiment that became famous, or infamous, depending on who you ask. He asked, if the late Cretaceous extinction hadn't happened, what might a Troodon descendant look like 65 million years later? The result he proposed was the Dinosauroid, a bipedal, large-brained, dexterous creature that had followed a similar evolutionary path to humans. Not a human, but something that might have found its own Stone Age eventually. Most paleontologists called this speculative, and it is speculative, but the fact that it's a plausible thought experiment, that we can even have this conversation about a non-mammal, says something real about where troodontids sat on the cognitive ladder. The living proof. Birds. Here's the twist that makes all of this hit differently. Dinosaurs didn't go extinct, not all of them. The avian dinosaurs, birds, survived, and some of them have done something remarkable with the last 66 million years. Corvids, crows, ravens, jays have neuron densities in their palliums, the higher cognitive region of the brain, that rival great apes. A crow has been documented doing all of the following: using a stick as a probe to extract insects from a crevice, dropping shellfish from height onto hard surfaces, and choosing the right kind of surface based on the shell, placing rocks into water containers to raise the water level and make it drinkable, a task that requires understanding volume displacement, using rocks as weapons dropped deliberately onto dogs, building multi-component tools from separate parts, and teaching other crows how to do it. That last one is key, tool knowledge being passed from individual to individual and then to the next generation. That's not instinct. That's the beginning of culture. Egyptian vultures use rocks to break open ostrich eggs, picking up a stone in their beak and hammering it down. Trinidadian motmots use flat stones as anvils to crack arthropod shells. The list keeps growing the more researchers look. And here's the part that puts everything in perspective. Birds diverged from the rest of the theropod line over 150 million years ago. The smartest ones are doing this now, 66 million years after the asteroid hit. Which means the raw cognitive toolkit was already in the theropod lineage long before the extinction. It was already there, waiting. The troodontids, the dromaeosaurs, they had access to some version of what corvids are working with today. Whether any of them ever picked up a rock and used it on purpose, we'll almost certainly never know. But the genetic and neurological groundwork, that was laid in the Mesozoic.